statistics? Well, that's a big question. One answer is it's about making decisions in the face of uncertainty. And we're trying to understand the uncertainty. And in the simplest case, we just have a mean. And so what do we do with the uncertainty? We characterize it using a distribution. So the most common distribution used is the normal distribution or the Gaussian distribution. So here we have a mean, and the uncertainty is here captured by the sigma or sigma squared. This is the exact same thing, it's just slightly different notation. For the Gaussian distribution, I just put in the sigma, and for the normal distribution, I put in sigma squared, but it's the exact same thing. All right, so sigma squared is a variance, right? So what do we call sigma? And there are unfortunately two schools of thought there. There are people who refer to it as standard error and others who say standard deviation. And so I use, in this class, I use the term standard deviation to refer to the square root of a variance of a random variable. So x is my random variable, which is normally distributed, for example. And then the square root of the variance, meaning sigma, is the standard deviation. And I use standard error when I'm talking about the square root of the variance of a function of a random variable. So for example, if I'm interested in the variance of x bar, and then I take a square root of that, that's the standard error. So standard deviation refers to just a random variable, and standard error refers to some function, average or some other function. Okay, so what do other people do? Some professors refer to standard deviations as the theoretical quantity, meaning the formula, how to compute it, and standard errors as the estimated quantity, meaning the numerical value that you get when you plug it into the formula. Okay, but we won't do that, so this is the last you saw of that. All right, you've all taken the Intro to Stats course, and so I'm going to see to what extent you remember this. Draw a sample from some population, and we get 3 data points. 3 data points isn't very much, but it's just for the point of asking the question. So what is the sample standard deviation of x, where we have 3 values and 5 possible answers? And I will leave you to answer this question. Given that we are online, you can look up the formulas and move on. And we have a similar question here, same data points. And now I'm interested in the standard error of x bar, so standard error of the mean. And I'm trying to express this as a function of the standard deviation. So here are 5 possible answers, and I want to see what the standard error is of x bar. All right, next slide. We distinguish between an estimator and an estimate, where estimator is the formula and an estimate is the numerical value. And in the earlier course that you took, some instructors made this distinction by putting in a tilde to make it clear this is an estimator. And when it's a numerical value, they put in a hat. I don't use the tilde here, because from the context, it's usually obvious whether it's one or the other. And it's also not widely used throughout statistics, so I'm just gonna stick with the hat here. All right, this concludes this segment.